So you might be thinking, so we have these two roots here, and then we have points over here and here. It doesn't look like we can draw a smooth curve through these, or it looks like it would be way too wide. But remember, look at the leading coefficient here in either standard form or root form or any of the forms. It shows us how steep the graph is. So since we have a 1/4 here, we know the graph is not steep at all. It's very wide. So the parabola is actually going to look something like this. We just have to connect the dots here. There is our graph. So we can see it passes through -1, 3, 7, 5, and 10, 14. That would just be up here somewhere. We don't have 14 up here, it'd be right about there. And we can see that the graph does approach that point. So we could go through the effort of finding the vertex. It would be at an x value of 2.5, and we would substitute that into this to find y. But we already know about what it's going to be. We can just look at the graph now and see that it's going to be just below 0, and that's because these two roots are so close together, and this graph is so wide that it just barely dips below the x-axis. You can barely even see it on this graph that it dips below the x-axis. But that is enough information. We have 4 points here. This is a good enough graph that we can say we did a good job there. So what we did was we started with 3 random points placed in very different, strange places along the graph, and doing a lot of solving and a lot of work to get here, we were able to draw a pretty nice graph. So that's pretty cool that we can start with such vague information and end up with a full graph. And on that note, I think we are done with graphing quadratic equations. What we'll do next is something that we haven't done in a while, which is inequalities. We're going to see what inequalities look like when they are quadratic.